Okay, so here is another circuit that I made up, so we'll see, if we end up with another negative resistance. What our job is going to be here is to find the voltage across terminals A and B. It's labeled VOC, that stands for V open circuit, to find, what is the voltage there. And the reason you might be interested in that is that might be the place where you're going to put something. So you'd like to know what the voltage is when you put it there. So what we want to do in this case, we don't really care how we change the rest of the circuit. We just want to get all of this over here and get it as simple as we can so that we can find out what this voltage is. Now, we can notice, like in the last problem that we did, that the 4 ohm resistor as drawn here is not going to play any role. If I then take some element and put it in here, then the 4 ohm resistor does do something, but right now it doesn't. So basically, V open circuit is the same as the voltage across this 2 ohm resistor. Well, now I do care a little bit about what's going on the other side of this circuit, because if I'm trying to find the voltage across this 2 ohm resistor, I don't want to transform that 2 ohm resistor, because that is going to change its actual voltage. So that I want to be careful about that. So I would need to do this in another sort of way. So what I am actually going to do is change the problem, because this one would use techniques you haven't had yet, and I'm going to change this voltage source to be a current source with current 5 amps. Okay, so now that I have that, now I can do a source transformation with my current source right here and my resistor. So when I redraw this, I'm going to leave out that 4 ohm resistor because it's not doing anything for me. And I have a 2 ohm resistor right here. And I've got a 2 amp current source right here. And a 5 ohm resistor right there. And these two are going to turn into a resistor and a voltage source in series. So my resistor is still going to be 3 ohms, and my voltage source will have that polarity because the current source was going down, and the voltage will be 15 volts. And now what I can do, and this is a typical source transformation kind of problem, by doing that, I put these two resistors in series, so now I can combine them.
Oh, you actually put 2 ohms instead of 3 ohms.
Thank you. And then, so that's now 8 ohms and 15 volts, and this is 2 amps. Okay, now I'm going to do another source transformation because I still have this current source over here. If I weren't looking for the voltage across the 2 ohm resistor, I would transform these. I would transform those. But I'm specifically looking for the voltage across that 2 ohm resistor, so I don't want to do that transformation. So instead, I've got my 2 ohms here, and I've got 2 amps here. And then this, did I change? No, that's the right polarity, right? No, I did the polarity backwards on this one. The plus should be at the bottom. I don't know, because the current source was pointing down.
Wait, it says B is negative, so does that mean that it's just going to go straight to ground then?
Where is, what?
Oh, well, on the original column, A is supposed to be positive and B is supposed to be negative. But is that just...
So with this being labeled positive and this being labeled negative, all that means is when you find VOC, that what you're finding is the voltage at A minus the voltage at B.
Oh, okay. So it doesn't indicate ground, right?
It does not indicate ground. If I were to work this problem, I would make that ground, and then the voltage at A, VA, would equal VOC when I do that, just because that's the way I tend to work things. Yeah, but no, it does not indicate ground. All the plus and minus is doing is telling you, when I'm talking about the voltage across this element, I mean this side minus this side. Because every element has two sides, and when I talk about the voltage change across it, it could be positive, could be negative, depending on which direction you're going. So that's what those pluses and minuses are saying. And it's not really even saying that A is a higher voltage than B. It's just saying, when I give this number, I'm saying it's A minus B.
That's just how they're measuring it.
That's just how you're measuring it. It could be a negative number. Yep. So that was something that took me a while to kind of grasp and accept. Okay, so here, so I don't think I labeled these, so that is what I intend on this one. So we had 2 ohms, 2 amps, and now I'm going to transform these. So I'll get an 8 ohm resistor, and I will get a current source pointing down, and that current source will be 15/8 amps. Now what I can do is say that all of these things are in parallel, and they're all in parallel with the voltage that I'm supposed to be measuring. And so if I get the voltage across any one of them, it's the same as the voltage across all of them. Or I can combine any of them and get their voltage, because the voltage across the equivalent of 2 of them together is the same as the voltage across the whole thing. So I can, with my resistors in parallel, so now I can simplify it. So I was resisting, changing the 2 ohm resistor before. Now, not so much. If I combine it with the 8 ohm resistor, that's not a big deal, because it will have the same voltage. So resistor simplification for resistors in parallel is product over sum. So that's 2 times 8 over 10. And then our current will be 2 minus 15/8. So now this is, so that's 16/10, that's 1.6 ohms. And our current source, 2 minus 15/8, it's going to be very small. 2 minus 15/8. 0.125. I knew that. Okay, 0.125. And it's going up because the 2 is bigger than the 15/8, which is why I have it in that direction. So since that's the case, I know that this side is actually at a higher voltage than the bottom side, because that's the direction the current is going. So my current, as it's traveling along here, is going in this side, through the resistor, and down that side. And so I know that I equals VA minus VB over the resistance. So, and this is the direction that the current is going. So VA is where the current starts from. Well, VA minus VB, that is exactly V open circuit that we're looking for. And I is 0.125. So 0.125 equals V open circuit over 1.6, or V open circuit equals 0.125 times 1.6. Which is 0.02 volts. Just 0.2 volts. Okay, so that is not a terribly ridiculous answer.
actual problem,
Uh-huh.
it has the 2 amps before the ohms. So I was wondering if that affects the problem.
It probably doesn't, so hold on just a second.